let's write an equation in slope-intercept form that represents the linear function that's presented in this table. So for this problem, we're trying to write an equation in slope-intercept form. So let's start out by recalling the slope-intercept form of a line. Slope-intercept form is y equals mx plus b. In this equation, m, the coefficient in front of x, represents the slope of our line, and b represents the y-intercept. So in order to write the slope-intercept form of our line, we need to find the slope and the y-intercept. Let's start by focusing on finding the slope. Then we'll worry about that y-intercept. To find the slope of a line, we need to recall the formula for slope. Well, what is slope? M, our slope, is equal to the change in y over the change in x. Or we could write it like this: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here, these x's and y's represent coordinates from two ordered pairs. And in this problem, we will get those ordered pairs from our table. Now, because we know that we're working with a linear function, we can pick any 2 points from our table to be the points that we're going to use to find our slope. In our table, the year is representing x, and the number of houses for sale is representing y. So here we have x values, and here we have y values. So to pick these 2 points, let's pick our first 2 entries. If we pick 2007 to be x, we must pick its respective y value, 95. So here, we will have our first point be 2007, 95. Our x value and then our y value. Then let's pick the second entry as well. So we will have the ordered pair 2008, 112. Perfect. Now remember, because we're working with a linear function, any 2 points would have done. But these will work just fine for our example. Now, we need to take these points and identify x sub 1 and y sub 1 and x sub 2 and y sub 2. In this ordered pair, 2007 is the x-coordinate. So let's pick that to be x sub 1. That means that 95, the y-coordinate, must be y sub 1. Then here, 2008 can be x sub 2, and 112 can be y sub 2. Perfect. Now, we need to take these coordinates and plug them into our formula for slope in order to find the slope of our line. So again, we bring down this formula, and we have m, our slope. That's equal to y sub 2 minus y sub 1, which would be 112 minus 95. And we put that over x sub 2 minus x sub 1, which is 2008 minus 2007. Now to get our slope, we need to simplify. 112 minus 95 is 17, and 2008 minus 2007 is 1. 17 over 1 is just 17. So that means that the slope of this line is 17. Since we now have the slope of our line, we need to focus on finding b, that y-intercept. Now there are a number of ways that we could find the y-intercept. Here, since we're already working with slope-intercept form, let's use that equation. So we have y equals mx plus b. To find b, let's plug in m, the value we just got for the slope, and then one of our ordered pairs to represent the x and y values. Let's pick this ordered pair right here, 2007, 95. So we have y, which is 95, is equal to m, the slope that we just found to be 17, times x, which is 2007, plus b. So now to get that y-intercept, we need to solve this equation for b. To do that, we take 17 times 2007. When we do, we get 34,119. To get b completely by itself, we need to take this value and move it to the other side. That means that we need to subtract that value from both sides of our equal sign. When we do, and we perform this subtraction, we get negative 34,024. And on the right, everything cancels except for b. So that means that b, our y-intercept, is equal to negative 34,024. Hey! Now we have our slope and we have our y-intercept. That means that we can find the slope-intercept form of this line. So in step number 6, let's write this equation. Remember, it needs to be in this form, y equals mx plus b. So we have y equals m, our slope, which is 17, times x, and then we want to add our y-intercept. But we found our y-intercept to be a negative number. So instead of adding, we need to subtract 34,024. And now we have an equation in slope-intercept form that represents the linear function that's presented in our table.